All righty, so here's the second half of the homework. My apologies to A Block. I didn't have this up, and as I put the problems on the board, I see there's some trig in there. These are all archived worksheets, and I would have told you that I don't expect you to be doing the trig yet. If anybody wants to learn how to do those problems, you can go to my personal webpage and look at, I think it's something about the unit circle there, how to get started with trig, unit circle work. Okay, so I do a video if you want to get another look at it. I'm a big fan of repetitive looks. So this homework has some other things in it that haven't covered yet. Technically, it's still all review, but some folks remote learning didn't get all the topics last spring. For whatever reason, might not have had enough practice with a particular topic. So this is what I'm hoping happens for you. I'm hoping that the problems that you know how to do, you get more confidence with and can do it quicker, right? That repetition allows you to complete problems, as I just stated, more quickly with confidence. And also, I'm hoping that doing this homework, you might pick up one or two more things. Something you didn't know how to do, now you can. All right, so I'm gonna have to layer the newer problems with a little bit of discussion. Just follow along. Try the ones you think you know how to do, and the ones you're not sure how to do, just play a video, okay? And we'll just keep marching along. All right, remember the goal. At the end of the semester, a decent foundation in the discipline. All right, so I think I asked you to double 37 units of torpor every 30 years, something like that. Well, that's typical exponential problem. So let me get to that. Let me do problem 27 first. All right, so problem 27, because I did 1 through 26 in the first video. Problem 27 is the null set. All right, in other words, I forgot to put a problem there. I was probably doing a little cutting and pasting for a new class, and maybe the Bruins scored. Well, they didn't, they're out of the playoffs. All right, so how do you double 37 units? Well, what's the amount that I'm starting with? Oh yeah, 37 units. I'm starting with 37. Yeah, that's the Y value I'm starting with. And what am I doing to it? I think I'm doubling it. If I keep doubling it and doubling it and doubling it, right? If I keep doing that and doing that, well, that process is exponential. Okay, so I initially start with 37. I put a 0 in there. And I put 0, anything to the 0 is 1. So that I get 37. Yeah, that worked. Okay, and now 30 years later, oh, 2 to the 30th. So that's times 2. No, that isn't doubling. I want that number to act like a 1. Well, I think I've got to get rid of that number and make it a 1. Oh, do you know something as simple as dividing this by 30? Okay, so I put a 30 in. 30 divided by 30 is 1. 2 to the 1 is 2 times 37, 74. And then 60 doubles it again, so on and so forth. How do you factor? 48 x squared y to the 9th minus 24x. And what does factoring mean? To write as a product. So I can take this and I may write it as first rule of writing products. What's the first rule of writing products? I hope if I ask it again, you respond, take out what's common. What's common? 48 and 24, 24. What's common? X squared and x. What's common? Y to the 9th n? Oh, no y's. 24x times what is this? Times 2 gets me back to 48. Times x to the, that gets me that. Y to the 9, that gets me the first term. 24, I guess I better put a minus 1 there. That is now a product. Products are helpful because if I divided this by that, I'm going to get this, right? Just so you know what we're doing and why. All right, so that's the product. How do you solve this equation? Well, you got those in algebra 1, right? How do you solve any quadratic? You set it to 0, and you hope that you can get a length times width equals 0 statement. So we bring the the 30 over, and we go, 5 times 6 is 1 apart. So we get our 5, we get our 6, and we say, okay, I want a negative. I guess that one gets the negative, that gets the positive. And we got our roots. At -5, I get a 0 in this equation. It solves this equation. I've got to stop there. These are the numbers that solve that. Okay, I'll elaborate on why I stopped talking later. Okay, A block, you got to this. I don't know if D block does or not. We'll find out. All right, so how do you solve equations? We had a nice chat, right? Order of operations chat and inverse order of operations. So what's the first thing you're going to do? Bring the -3 over. Divide -3, so that's -1. So that gives me log base 3 of x minus 3. And we talked about the inverse of log base 3 is the inverse of finding exponents is using the exponent. Okay? The inverse of finding, because log means to look for the value of an exponent. Well, there it is. That's the exponent. And the exponents go on top of bases. So it's rearranging this thing. So x minus 3 equals 3 to the -1. We're learning what that is. And so x is equal 3 to the 1/3. So let's plug it in. 3 to the 1/3. I should have plugged it in up there, but we'll do it here. 3 to the 1/3 minus 3 is 1/3. What is the exponent you put on top of 3 to get a 1/3? -1. Okay, so that's that problem. All right, so I did this. This is only the second time you've probably done this. I think bar graphs are great. You can see the x's go up by 1. You know, the first one gets 11, the next one gets 5. It's just a way to visualize with some good approximations. Okay, so I'm a little less than halfway. That might even been down a little more, but I'm starting to see a parabola. And so where's the vertex? Right here, and I believe that was 5, 3, right? And I can see 7 gets 11. And we're practicing that in class, aren't we? X minus 5 squared plus 3 using the vertex. And its x value, that's called the abscissa. That's called the ordinate. Got to get fancy in math, you know? The x and y values. All right. So when I put a 7 in, I'm getting a number, right? We talked about this. How do you turn the 4? Because when you put 7 in, you get 4 units. And 4 plus 3 is not going to work to get to 11. So how do we change that? With a multiplier. Get rid of the 4 and bring in the number that will take you from 3 to 11, which is 8. So 8 over 4. So that was that function. And if you want to check if it works, try something else. Put another number in. Let's put the number 4 in and see if we get, I guess that's a 5, huh? Let's put 4 in and see if we get a 5. 4 minus 5, -1 squared. 1 times 2 is 2 plus 3 is 5. Boy, work for that, work for that, work for that. I think it works. Of course, you can say 2, right? Okay. Now, here's a new problem. Here's a new problem that's designed to help answer a question in calculus like x squared minus 4x plus 3 divided by x minus 2 dx. What is that? Okay, that means nothing to you right now. But the ability to answer it resides in being able to divide, right? Putting this on this side would be division. We get a statement like that. Now, I've never had, in all my years of teaching Calc AB, anybody be able to do that correctly the first time in Calc AB. Why? Because they don't know how to figure out how to rewrite this. If they knew how to rewrite this, you know, I could rewrite that one quickly, and this one as well, they could have done the problem. The calculus was not the issue. It was the foundation. So we're going to do a couple of these, and these, you know, some people pick up on them on a day or two, and some people take a month. All right, but I'm going to do it in a way that I hope is a little easier this time around, and then I'll morph it into something. All right, so x minus 5 times what gets us x, I'm going to do this differently than I usually do, so I'm going to make a space here, equals x squared plus 5x minus 3, okay? Now, you're looking at something and you're going, what the heck am I going to do with that, right? You got a marker. You get to make this thing work. Okay, so what do you think you put in here first? Well, I'll leave the what here. Right? I want to make sure that we can see everything. Yeah, we can. Well, what am I going to multiply x by to get x squared? X. Okay? What do you have right now? Right now you have the first term correct. The next term is not correct. Minus 5x doesn't work. What does work? Well, I've got to get to 5. Positive 5. I'm at negative 5. How do you get from negative 5 to positive 5? I think you got to add 10. Right? And what is 10 times x? Oh, that's 10x. I'm adding that to minus 5x. I now have the second term. Okay? And what's minus 5 times 10? Minus 50. But I got to get to minus 3. I got to go up 47 units. If I multiply this out and add that, I get what I was looking for. Now, I generally don't write that way. I generally put it inside. And if I put it inside, when I multiply this, I don't want all that, right? I only want this number. So if I multiply that and then divide it by that, I've got that number. And that's the way. And if I integrated that, I'd get x squared over 2 plus 10x plus the ln, 47 times the ln of x minus 5. And all my calc kids could do that after we study why it works. They couldn't get this statement. Hence, we're going to practice it, so if you encounter that, you will be able to get a correct answer. Remember, that's going to take you a couple of weeks to get to this point here. If you want to find out if you're right, what makes a 0 here? What's the critical number? It's 5, yes? I'm going to put a 5 in here. 25 plus 25 minus 3. Geez, that's 47. Wonder where I've seen that number before. Okay, so let's do one more of those. One more. I said I wouldn't layer this, but I can't stop myself. Let's try one more because it's the first time you've tried it. Let's do x minus 2 times what gets me x squared plus 9x minus 3. Okay, you can pause the video and try. I'm just going to do it. So I got x, I got minus 2. I got to get from minus 2 to 9. I got to go up 11. I'm at minus 22. I got to get to minus 3, so I got to go up 19. So I'm going to put it here. 19 over x minus 2. I want to find out if I'm right, so I'm going to put a 2 in here. And I get 4 plus 18 minus 3, which is 22 minus 3, which is my positive 19. I can move along. Okay? We'll do some of those in class tomorrow. Get you started on that. And it'll be on every test for the rest of the semester. All right? And I have utmost confidence in you that when you leave the door a month and a half from now or whenever the heck we end, you'll be fine with that. All right, so I think I asked you to change this to slope intercept. This is the third time on a homework you're trying it. Let's see how you do. So this is equal to minus 3/5 x minus 12/5 plus 45/5. Right, that's that number, yes? All you had to do is this times that to get that. And you have minus 3/5 x minus 12 plus 45 is positive. Oh, brain's slowing down, 33 over 5. Okay, I believe. I hope you didn't make a mistake there. All right, now I'm hoping you follow that better or do it yourself with more confidence and getting it right. Okay, that's what we're trying to do with every problem. And if you are doing that more confidently and getting it right, it's probably because you've repeated it several times and you have not yet had the opportunity to repeat this stuff. Okay, so no anxiety, not allowed. Okay, I understand this stuff takes time to learn. All right, so 3 coordinates. 3 coordinates, something in point slope form. Can you see what makes a 0 on the right? Well, I should have shut up for a little bit here, give you a chance to at least see the problem. What makes this equal 0? An x value of -1. It's crying out. It's crying out to be used. What number is crying out to be used here? You put those numbers in for x and y, then you get 0 equals 0. You get truth, justice, and the, well, I don't know if we have that anymore. Oh yeah, we're trying to get it. We will get there. I have faith in this generation. All right. Oh, change in x. I'm going to change my x's by 2. Well, I could do that forever. I could go backwards. But I prefer you to go forward. It's easier for me to correct. Oh, change in y. Oh yeah, I'm trying to get to sleep tonight. Count by 3s backwards. Never worked for me. Okay, so hopefully that maybe more of you got that right this time. All right, product. Well, write down what has to be true. That has to start things off. what has to be true? I'm either multiplying 1 times 25 or I'm multiplying 5 times 5. If I put 25 in here and triple it, I'm at 75. If I put 25 here, I've got 25 and then 3. 25 and 3? I guess it's got to be a 5 and a 5. Now, I want minus 20. Well, that's minus 15. There you go. All right, so writing products is about trial and error. And always try to write down what has to be true. Then you have less to consider. Okay? So I want to give you a little factoring every day. And what's the first rule of factoring? Take out what's common. What's common? Nada. So I didn't take anything out. All right, moving right along. All right. Algebraically and graphically. That's what I mean by A and G. Algebraically and graphically. Okay? That's what the last page is, which I'll do for you. I apologize for the trig again. It was there and I didn't see it because I didn't do this video until now. All right, so this is a graph. Ignore that for a minute. What are you looking at? You're looking at a calculation, and when I put different values for x in, I get different values for y. And if I want to see the numerical trajectories, that's what a graph is. A graph tells me if something is increasing, or if something is even increasing faster, or increasing at a decreasing rate, right? It gives me a sense of, what's going on when I put a million in for x? Oh, it's starting to look like a constant. It's starting to look like a constant over here. Okay? So that's the kind of information that comes from a picture. Picture's worth 1,000 words is the cliche, right? So what is the absolute value of x? Well, here's y equals x. That's the graph of y equals x. Okay? What happens when I slap an absolute value on that? All of these negatives become positives, right? So what is the shape of an absolute value? A V shape. So this graph has a V shape, up or down. It's just like a parabola. Is this positive or negative? Positive, so it's V shape up. And what do we call that? We call that a vertex. All right, I've got it, it's 5, 6. Now I think, and this is what I'd like you to do with absolute value, vertex, shape, and always get the y-intercept. It gives you a sense of size. How do I find the y-intercept of the left side of this equation? Plug in 0. 0 minus 5, minus 5. What's the absolute value of minus 5? 5 times 2, 10, plus 6, 16. 0 is to the left of 5, and I get 16. That's helpful, okay? Because now I don't want a height of 16. I want to know where it hits a height of 20. And that's 10 units of change. And I got to go another 4. I think my roots are right about here. Okay, and if that's 0, 16, over here is 10, 16. Okay, so I now know I've got a number maybe near 12. Yeah, I'm cheating here, right? I'm looking at a rate of 2 to 1, right? And probably negative 2. Because what is the graph of y equals 20? It's a constant. Okay, so I have an absolute value intersecting a constant. And what did I say when you solve equations? You're really finding x value of intersection. All these functions, that's what you're looking for, the x value of the intersection. Okay, now we got to solve. Well, I hope you can tell that this is going up at 2 to 1, up. We read graphs from left to right. This is really coming down at 2 to 1. So if you looked at the y values, they would be coming down to 6 and then going back up. Okay, we went from 16 to 6 to 16, down then up. So the easiest way to do this, the easiest way, there's actually a quicker way that I'm going to show you. But the foolproof way to do this is to take the slope on the left side and change it into the line, set it to 20, and then take the other side, which is really a piecewise function. These are the two pieces. Well, that's one piece. This is the other piece. And feel free to do this. 20 take away 6, 14. 14 divided by -2, -7. -7 plus 5, -2. Bingo. I think we said that's what it would be anyway. Then over here, you can always go to this and just change the sign, but subtract 6. 14. Brain's getting tired. 14. Divided by 2, 7. So I've done that. Adding 5, 12. Right? Does it look like 12? Does it look like -2 for x's, points of intersection? I've done it 2 different ways. It matches up. I'm feeling good. I feel fine. Do. No, forgive me. My mother had a scholarship to the Juilliard. I did not inherit her voice. She didn't get to go. Why didn't she get to go? Because women back in the 1950s had the short end, right? Her mom passed on, and she had to take care of her dad. She had to drop out. She was in Smith College at the time. She had to drop out. We need some systemic change here in a lot of different ways. Ooh, I must be getting tired when I start talking like that. All right, back to the math. I'm sure this is the one that's going to give you trouble. I told you I'm really going to come after this at midterm, but it's on the sheet, so I'm just going to do it. First time I looked at that, I had no clue what to do with it. All right, so we got 20. I know what to do with that from the last problem. I'm going to call this 20. Right, that gives me a quick ruler, so that's about 10 units right there. I see some highlighted numbers. I see 3. I see 3 critical. What do I get if I put a 3 in there? Oh, 0 over -1. Well, I know that's 0. So it looks like I get my x-intercepts. I think that's 20. I'm going to call that 3. So I got an x-intercept. I'm well on my way to graphing this, but I need more information. I know how to get a y-intercept. Let x equal 0. That means I'm covering up the x's. And I get -3 over -4. So I get a y-intercept, -3/4. Okay. Oh, I know that if I put a billion in here, let's just put 3 zeros and subtract 3. And if I put 3 zeros and then subtract 4 and I divide those, sure looks like I'm pretty close to 1. So it looks like over here, end behavior is asymptotic, is 1. What happens when I put a 4 in? When I put a 4 in, I get 1 divided by 0. And if you said 0, then just like 6 divided by 2 is 3. Can you see this? I know this is true because 2 times 3 is 6. So if you think 1 divided by 0 is 0, then I guess 0 times 0 has to equal 1. Oh, no, it doesn't equal 1. Oh, that's right. You can't divide by 0. So I'm a computer. I go over here and I say +4. Oh, I can't divide. I can't use that number. I'm not getting anything out. I know this goes to 1. Well, what's it doing here? I got a feeling it's got to do that. And I know there's only one x-intercept, only one place it crosses. And I know I end up here. I guess it's got to do that. Let's put 4.001 in here. 4.001. What happens when I subtract 4? I get 0.001, and this is going to be near the number 1. That's a pretty big number. This little guy fits into that lots and lots of times. Okay? So I haven't done justice to the cause, but we've started the conversation. Okay, we started the conversation. Now, where do I hit 20? Okay, so I'm looking for a number a little bit bigger than 4. I don't know how good my drawing is here. All right, I'm going to guess 7. Let's solve it and find out. Oh, I'm going to multiply. I'm going to move it. Oh, that's 20x minus 80. Oh, I'm going to bring my x that way. That's 19x. I'm going to bring my 80 this way. That's 77. How many times is 19 going to 77? Boy, did I take a bad guess. This critter really came down quickly. 77 over 19. That's pretty close to 80 over 20, right? So this number is a little bit bigger than 4. I'm guessing it's probably 4.15, something like that. Okay, so that probably threw you. I know when I first looked at my first rational function, well, I want to go back there, right? Because it's like somebody doing it for me, and I'm like, and I said, well, I know the x-intercept's 3, and I'm like, okay. All right, so you're going to have to do a bunch of those, but I'm really going to concentrate. Well, we'll keep doing them on the worksheets if they're there, but I'll try to give you some graphs and some, some layering of why that works. So what is x squared minus 6? X squared plus 0x minus 6 is another way of writing x squared minus 6. 0 tells me I'm not going up or down at the vertex, or at the y-intercept, excuse me. So I have 0, negative 6, and I'm flat there. Okay, well, that must mean it's the vertex. It's got to be the vertex. And it's just the parabola moved down, just the parabola moved down from the origin 6 units. And y equals x is that graph. So I can see I have 2 points of intersection. One of them is closer to the origin than the other. It's negative and positive. All right, let's go find them. See if it makes sense. How do you solve this? We did one earlier. X squared minus x minus 6 equals 0. Oh, okay, I think that's factorable, right? I either got 1 and 6 or 2 and 3. Well, 2 and 3 are 1 apart. So I know I got a 2 and a 3. And I want this one negative, negative positive. All right, so what was this coordinate? 3 for the x. Oh, I could have plugged it in here. 3, 3 is where they intersect. And they intersect at negative 2, negative 2. Okay? Now remember, I gave these worksheets out years and years and years ago, and I think I mentioned I had a new teacher, soccer buddy. He played soccer with us, and he's the head of a school now, and he had a PhD, right? And he came across the room, and this first time he encountered a question like that, he said, well, what do you mean to solve it graphically? Okay? So, I know it's not something that you've probably done, but in calculus, you've got to be able to find areas between two curves. You might have to find this area, right? Of course, they don't write it like this. They'll say, find the area between the curves x squared minus 6 and y equals x. That's how the question will come your way. But you got to be able to graph that, all right? And I want you to have success. So we're going to practice it. All right, another absolute value. Hey, maybe you can do this one quicker. Then about 10 minutes since you did the last one probably. That's great, you had enough time to forget. Let's do it graphically first. What kind of graph is absolute value? V-shape. This one's down. What's the vertex? Negative 216. All right, so I know 0 is over here, right? 0 is bigger than negative 2, so I want to find the y-intercept, so I plug a 0 in. 2 times negative 3, negative 6 plus 16. Oh my God. Oh no, negative 6 plus 16 is positive 10. We want negative 10, which is down here somewhere. Negative 10. All right, so what are we thinking? That changed by only 6 units, and I got to go down 20, so I got to do this about 3 more times. So I got to do this, I got to add about 6 units to that. So if I get an answer near 6 or 7, I'm going to be happy, all right? And then, of course, the reverse would be about 8 units this way, near negative 10, I'm guessing. All right, let's actually solve it. All right, so what am I doing? I'm going up. In this direction, I'm going up. In this direction, I'm going down. At what rate? 3 to 1. So I'm going to do the up first. The up is 3 times. I'm going to do this side intersection. Now, let's do it number-wise. Let's do left-right. So let's just do negative 3, x plus 2. It doesn't matter. All right, let's do that one. So 16, take away 16 minus 26. That takes care of that. Divide by negative 3. Oh, I gave you a fraction. I'm sorry. 26 over 3. And then we're going to subtract 2. Subtract 2. Well, how do I express 2 in denominator 3 terms? 3 times 2 is 6. Right? So this is 6 over 3. So one answer is 20 over 3. And that is this intersection here, the one that's coming down. So that is an x value of minus 20 over 3. Now, let's estimate minus 20 over 3. Positive 20, sorry. See, that's the beauty of this. I caught a careless error. Well, 20 divided by 3 is pretty close to 21 divided by 3, right? which is 7. And I was guessing, oh, I'm near 6 or 7. You know, how did I guess? I dropped down 6 units. I went over 2. Well, I just continued that process. Well, I know I got to do that a little more than 3 times to get from 10 to negative 10. 20 units of change. 3 jumps of 6 is 18. So I knew I was a little more than 6 that way. I'm talking to myself or not. All right, positive 3 is this one. Okay, so we just got to go backwards and do the positive 3 now. That's the nice thing about a board. So I'm going to subtract 16. Here's still negative 26, but now I'm dividing by 3, which is minus 26 over 3. And then I got to subtract 2. Right? So hopefully you're seeing minus 26 over 3, minus 6 over 3, and that's minus 32 over 3. So that's this intersection here. That's the x value, minus 32 over 3, which is near minus 33 over 3. My guess was somewhere near negative 10, negative 11. Well, that's negative 11, so this is pretty close. Okay? All right, now, I don't know, D block, if we're going to have e to the x done yet or not. So we'll see. I guess I better talk about it later today. I'm doing this on Wednesday morning. All right, so how do I graph? Well, I can always graph stuff with a table, right? And if I was picking a table, I would have picked stuff like, what do I want to put in here? I want to put numbers. I want e to the stuff like e to the 0.7, e to the 1.1, e to the negative. Those are the numbers that I want, right? That's the formative. You know, you got to take time to memorize those values, okay? But the shortcut is to know the shape of e to the x, positive e to the x, right? So we have, I'll do it up above. So we have an asymptote. Do you remember from class how you get the asymptote? This is growth. This is growth right here on top of 5. I've got growth on top of 5. Okay, so there's your shape. Now all we need is 2 values over here. Well, I know these 2. These are the 2 I like. I like e to the 1.1. I do that every time. And I do e to the 0. So I pick 0 and whatever gets me 1.1. In this case, I'm putting in 3.1. Okay? What is e to the 0? 1 plus 5 is 6. This is 0, 6. And that's 1 unit of change on top of 5. Okay? I'm now going to make this 1 unit of change is actually the a value. It's actually that. I am now going to triple that when I use this number. So 3.1 minus 2 is e to the 1.1. What is e to the 1.1? Approximately 3 times that. That looks to be about 3 times that. And that's on top of 5. So I am near the number 8. 3.1 is near 8. Okay? So now let's solve it. What's the inverse of addition? Subtraction. What's the inverse of division? Multiplication. What's the inverse of squaring? Square rooting. What's the inverse of e to the x? ln of x. What's the inverse of ln of x? E to the x. What's the inverse of e to the x? ln of x. What's the inverse of ln of x? E to the x. Let's do the problem. Oh, I want to hit a height of 25, right? 25 is way up here. I got to have a number bigger than 3.1. Step 1, subtract 5. Step 2, the inverse of e to the x. The inverse of e to the x is ln of x. And then add 2. Okay? Now, I can get you an approximation of that without a calculator. You can't do that skill yet. It's coming, though. All right? Go to your calculator. Type ln of 20. ln of 20. Let me just take a guess here. I don't do ln of 5 that much. I don't do that much. So I'm going to be off a little bit. I think it's about 1.6, 1.7. I'm not sure. I'd have to check that one out. But I know that 20 is equal to 4 times 5. And I know 4 is 2 squared times 5. I know 2 is e to the 0.7. So this exponent is 1.4. And I know multiplication is addition. And I think 5 is about, the ln of 5, I think it's about 1.7-ish. So this is 3.1-ish. And if I add 2 to that, 5.1, so I had a bad guess. Well, no, I didn't have a bad guess, right? It's not a bad guess, okay? But if you want to find out, what that is, it's going to get you an answer that's just a little bit bigger than 25, because I'm overestimating these just slightly, okay? But you're going to be close. If you put this in the calculator, I'm going to guess you're going to get 25 point, maybe 1, 2, something like that. I'm going to check it out later on my time. Okay, now, I covered this in my Algebra 2 extensively the entire term with my Algebra 2 kids, right? It takes time to learn this, right? I'm guessing you probably didn't spend much time on it, and you probably have no idea what that even does yet, okay? We'll get there. This is just mechanics right now, but I already forgot what the inverse of e to the x is. Oh, ln of x. Let's see if that's true. Let's see. E to the 0.7 is approximately 2. Is 0.7 on a calculator? Close. Is that ln of 2 going to get me that value? So if I didn't know what this was, if I didn't know what that value was, I could go to the calculator and do that, and it'll tell me, yeah, that's the purpose of that function. And you can't do it in your head. You got to push some buttons. You got to go to Google or a calculator to get some of these answers. Okay? Yeah, I'm talking a lot, aren't I? All right, so ln of x. We're going to graph the ln of x now. And what is the ln of x? It's exponents on top of e. All right, that gets you what you want. So let's see how you do. Do you know what you get when you do a third? The ln of a third? Negative 1.1. Why? Because e to the negative 1.1 is a third. Do you know what you get when you do a half? Checking your memorization, seeing if you're looking at that chart. Negative 0.7. Do you know what you get when you get a 1? You notice these numbers are getting bigger, right? So I'm moving to the right on the graph. So let's call this 1. Let's call that a half. Let's call that a third. 1/3 gets me negative 1.1. 1/2, so that's a third. 1/2 gets me negative 0.7, and 1 gets me 0, right? The ln of 1 is asking, what do you put on top of e to get 1? That's a 0, right? So I've got this much of the graph. I think I could do a 4th, a 5th, a 6th, a 7th, an 8th. I think it's doing that. I can't do the ln of 0. Remember, e to the x is always above the x-axis, and we're doing the inverse. I probably just confused you. All right, how about 2? What do you put? Oh, yeah, we just did that. That's positive 0.7. Oh, 2 gets me positive 0.7. And what about a 3? Oh, yeah, 1.1 is what you put on top of e. And that's over here. So there's your graph of the ln of x, which is the inverse of e to the x. If you switch these around, that's that graph. This is that graph. Okay? No way can you pick that up, right? I did not know the purpose of ln of x. I mean, I could get kids to get it right on a final exam. I didn't really understand the ln of x until 5 years ago, okay? And I got a little secret for you. I'm not hearing too many people talk about what it's really about, okay? So, going to share some nice information, I hope, about that function. So, first step, follow. Second, do. It's going to take some time. We got the semester. All right, next problem. Square root function. Yeah, hopefully everybody remembers what a square root is. You know, it's the dimension of a square. I hope I didn't just get a blurry. I do that all the time. Okay, so square roots. So what is x minus 5? It's got to be an area statement. In order to get a square root, like Let's call this 4. In order to get a square root, you need area. How about 1? 1. How about 0? Square root of 0 is 0. How about the square root of negative 1? Imaginary. Right? So this thing has a starting point. This is 9. Gets you 3. So these are your inputs. Your inputs are the area. What do I see? Those numbers are going up faster than this. So I've got a graph that's going up. It's going up. It has a starting point, but it's going up in a decreasing way. Okay, so I'm graphing this right now. All right, so how many points do I need? Well, I definitely need this point. Can you intuitively tell me what it is? Well, if I put a 5 in there, I'm mimicking the square root of 0, which is the start. Now, it's not a vertex, it's an endpoint, I believe. I don't think I can call that a vertex. Yeah, I can get my terminology down here. All right, now, any one of these numbers is user-friendly. Those are user-friendly numbers. Why don't we make this thing 9 units? No, that's the one I don't want to use. Let's make this thing 4 units. Well, if I make this thing 4 units, I got to start with the number 9. Okay, so I've got to start with the number 9. I already can see that a 5 gets me a 2. So I'm going to put a 9 in here. Oh, that's the square root of 4, which is 2, and 2 plus 2 is 4. So why don't we call this 9, 4? Okay, that's 9, 4. And I wanted that one up 2. I got to go up another 3. I'm here somewhere. Right? I'm here somewhere. So my x is going to be, I don't know, something in the vicinity of 20. Let's go find it. Subtract 2. Square. Add 5. Boy, was I off. 30. I'll take it. I know it took a while to get to that height. Okay, so let's check it. 30 minus 5, 25. Square root of 25, 5 plus 2, 7. There, I did it 3 different ways. All right. So sorry I chatted. I didn't want to, but I felt like I had to because there were so many things here that technically you've done last year, but I'm guessing they're not in your pocket. All right. And if you want to go to the next level of study, it's got to be in your pocket. So, you know, we have probably covered in the first 3 days. If you came away with an understanding of just these worksheets, you're halfway there. And obviously, the intersection of these graphs, we're a long way from having that in our pocket. But this is how much material we've covered. Maybe more than 50%, because trig is probably 30% of a pre-calc course. Okay? And we'll get to that at some point. But I've thrown a lot of the course at you. Now, obviously, some of the problems are going to get a little more in depth. Okay, some are going to get a little more in depth, but we got a good start here. We got a good chunk of material in front of us, and your challenge is to come away from this homework knowing 1 or 2 things they didn't know before, or following it better. Okay, because the first step is following, and if you could follow it, you'll do it yourself. All right, and then at some point, I'm going to grab you and have you explain it to groups, because the nice thing is the science teachers need that other room, and we've got a real good solution. I'm in another classroom adjacent to that one. There's the door back there, right? You go through that door, and we're in the room that I was in this morning teaching Joel. So we're going to have one group on this wall, maybe 3 or 4 people. We're going to have 3 or 4 people on this one. We're going to have 3 or 4 people on that one. And you're all going to have the worksheet right with you. And you're going to do a problem, and you're going to write your answer down, and then you're going to get to look at what other people have done. Okay? And we're going to practice 2 sentences. Somebody's got something wrong. They know it's wrong. You have to learn how to say, can you help me? And then the person or persons that is being asked that question, you have to learn how to say, yes, I can. It would be my pleasure. Okay? So that's what we're going to do at the board. And so we're going to have 6 groups of 3, I think. And the other rooms got plenty of whiteboards too. We're going to spread out. We're going to go back and forth, you know, just making sure that, you know, just like on a bicycle, you say, passing on the left. You know, if we go in between rooms, passing on the left. All right. And I don't see any reason why we can't have ourselves a nice interactive, get you out of your chair, start doing them at your own pace. Okay, at your own pace. All right. And then let's see if we can go up the ladder on those tests. All right. All right. I hope I didn't exceed my time. If you don't see this uploaded to your Canvas, then it's going to be on my webpage. All right? One way or the other, we're going to get that video out there. All right. Thanks, everybody. See you tomorrow in class.